reacting. You should know how to balance the chemical equations. Once you know how to balance the chemical equation, it will be very easy for you to solve any question. But if you don't know how to balance the chemical equation, it will be very difficult. For example, you should know what is reacting. You should know what a precipitate. You should know what a product and reactant is going to form. For example, if a limestone reacts now, what will it form? Now, if it undergo it, it's going to form what? It's going to form CaO plus CO2. So once you know what is going to form, it will be very easy for you to solve questions. Maybe 1 gram of this react with this. They will now say you should look for quicklime. If you look for quicklime, then which one is quicklime? You can find quicklime, and you can find this one, the next TP. You can find the volume of H2O once they give you the mass of this. Another one is that when organic compound reacts, we actually know that it is going to give us CO2 and H2O. It's going to give us carbon dioxide and water. So how do we know that? For example, let me take example of methane, for example, plus O2. Now, this is how organic compound is. When it reacts now, what will it give? It's going to give CO2 plus H2O. But once you don't know what is reacting, you can never get it. But in order to balance the equation, this is 4 hydrogen now. You put 2 here. Now, you balance the oxygen. 2 oxygen, that is 2. You balance it. So once you know what your equation is going to form, to solve will be very easy for you. For example, if zinc reacts now, which is solid, when it reacts with excess hydrochloric acid, which is react with acid, what will it be the product now? The product will be zinc chloride plus hydrogen gas. And now, this one is 2. You just add 2 here. This one is 2. So the equation has been balanced. So once you know what a reactant will form, what a product will form, it will be very easy for you to solve a question. So let's now go to example 1. In this example 1, see how we are going to solve a question that involves oxygen, and how we are going to relate equation of chemical reactions together. 1. What is the mass in gram of 0.5 mole of oxygen atom? Now, we want to solve for oxygen atom. Now, 0.5 mole of oxygen atom. Then I said we should take O as a thing. You know that 1 mole of oxygen gives what? Gives 32 gram, because it's diatomic. So it will give 32 gram of O2. So 1 mole of O2 gives that. So now 0.5 mole of O2 now gives what? So it will be 32 times this now, times 0.5 all over 1. So that gives us 16 gram of O2. So that is what you are going to have. So that is what he is going to give us. Let's take example 2 now. How many mole of magnesium atoms are present in 0.5 mole of magnesium? So how can we solve these questions? So 1 mole of Mg gives what? Gives what should I call it, 24 gram, because we are doing ourselves to take Mg as 24. It's monoatomic. So now 24 gram. So now 0.50 mole gives of Mg gives X. So now if you are reacting it, it will be 0.50 times 24 all over 1. So that gives us 12 gram of Mg. That is the solution. It's just easy as ABC. And if you want to use alternative method, you can use number of mole. Number of mole equals to reacting mass, which is amount equals to reacting mass all over molar mass. and the reacting mass is what we are looking for. So now that means reacting mass equals to reacting mass equals to amount in mole times molar mass. So what is our amount? Amount is 0.5 mole times molar mass. Molar mass of magnesium is 24. That still gives us 12 grams of Mg. So it's the same solution but different working. So we can call it this one alternatively. The first example too, you can try it like that. You can use this mass and this, but note that in the first question we call this one diatomic. So don't use 16, you are going to use 32 because it's diatomic. It is not mono, it is diatomic. So let's go to the third example now. The third example, now we are given equation of neutralization reaction. You know, when acid reacts with base and it forms salt and water, so that is called neutralization reaction. And in this neutralization reaction, the equation is not balanced. In order to balance the equation, you have to look at the left hand side whether it's balanced with the right hand side. We have 2 here, we have 1 here, so we put 2 here. So that becomes that this side has been balanced now, this side has been balanced. So we have not balanced hydrogen. Let's balance hydrogen now. How many hydrogen do you have here? You have 2. How many hydrogen do you have here? You have 2. So you put 2 here. So that means that the equation is now balanced. So how many oxygen do we have? We have 5 oxygen. And if you count the number of oxygen that we have here is 5. So that means the equation is balanced now. So let's go by solving the question now. The question says that from the equation above, how many grams of H12SO4 are required to react with 0.5 mole of NaOH. So in the other question we solved the other times, how many in gram of magnesium atoms are present in 0.5 mole of magnesium? How many gram? Not how many mole, it's how many gram. How many gram of magnesium atoms are present in 0.5 mole of magnesium? So we have started to calculate the grams as 12 grams of magnesium. But in this equation now, again, we have balanced the equation. The equation says from the equation above, how many grams of H12SO4, how many grams of this, are required to react with 0.5 mole of this. To react with 0.5 mole of sodium hydroxide. In order to solve that, what you are going to do is that you know the question asks in gram now, and we are giving this one in mole. So what are you going to do? What you are going to do is to solve this one, is to solve for this and look for this. That you can use any method. You can use this one in gram, and finally you get this one too in gram. But now, if I want to solve this, I can use number of mole, which is equal to reacting mass all over molar mass. So what is the reacting now? What is the molar mass? So now, before you react it first, what you are going to do is that 1 mole of this, 1 mole of H2SO4 react with what? React with 2 mole of NaOH. Is to react with 2 mole. So now 0.5 mole of NaOH react with H2SO4 of X. So you need to find the ratio first. So that means we have 1, 2, and we have 0.5. and x. So if you solve there, you have 2x equals to 0.5. So that means x will be equals to 0.5 over 2. That gives us 0.25 mole. That gives us 0.25 mole of what? Of 0.25 mole. 0.25 mole. 0.25 mole of the acid now, H2SO4. That is what we are having here, 0.5 mole of H2SO4. So now we can now find the gram of H2SO4. So since we have the number of mole now, so now we can say that we can use two methods. You can use any method you like. You can say that 1 mole of H2SO4 gives this. What is the molar mass of this? Let's quickly calculate that. That would be H2H plus X plus 4O. That gives us 2 times 1 plus 32 plus 16 times 4. Don't forget this 4. That gives us 98 gram per mole. So now that's how to calculate molar mass of H2SO4. So now I just want to clean this side in order for you to know. So for me to clean that side, I have 1 mole of H2SO4 gives 98 gram of what? H2SO4. It's still the same mole, 0.25 mole of H2SO4. It's the same thing as reacting, gives X. That now be 198 and 0.25 X. So that gives us X equals to 98 times 0.25. To change it to fraction, we have 98 times 1 over 4. So from there, what are you going to have? 2 here, 2 in 9. 2 in 9, what will it give us? 2 in 9 will give us 4, remainder 1. In 18, 2 in 18, 9. So can 2 go again? 2 here, 1. 2 in 4, 2. 2 in 9, that is 2 in 9 will give us 4, remainder 1. Remainder 1 in 10, that will give us in 10, that gives us 5. That gives us 24.5 gram of what? Of H2SO4. So that is in gram. The question says that from the equation above, how many gram of H2SO4 are required to react with 0.5 mole of NaOH, and we have actually calculated that to give us what? 24.5 of H2SO4. And you can use another method too. If you want to use another method, what can you do? If you want to use another method, amount, which is a mole, equals to reacting mass all over molar mass. And now we want to get our reacting mass. Reacting mass equals to, what should I call it? Equals to amount times molar mass. So you don't write it in full this time around. So you just write it in form of a symbol. So this is molar mass, this is amount, which is a mole. That is number of mole. So now, what is our number of mole? Our number of mole in the question is 0.25, because that is 0.25 of NaOH. But in terms of this, it is 0.5 for NaOH. But for H2SO4, it is just 0.25. This X is 0.25 that will react 0.25. This one is 2. This one is 1. So if this one is 0.5 for 2, so that means the 1 will be 0.25. And we have actually calculated and seen there. So times molar mass is 98. That gives us 24.5 gram of H2SO4. That is what we are going to have from there. So now we have actually talked about mass and volume relationship. Let's take another question in order to summarize what we have been discussing. So we now move to volume. Remember, we have the question under volume. How can you calculate it? We have been talking about mass, we have been talking about equations and how we are reacting them and how it's giving us answer. But now, just watch. how we are going to calculate the next question based on another question we have says that what volume of oxygen at XTP is required to convert 60 grams of carbon completely into carbon 4 oxide. So when you have this type of problem, what is very necessary for you to do first is to know how to write your equation. Once you can write the equation, to solve the equation will be very easy. But if you don't know how to write the equation, there is no how you are going to solve it. So if I want to write the equation now, I'm going to have, what am I going to have? I'm going to have C, which is solid, react with oxygen gas, react with oxygen, which is gas, in order to give us carbon 4 oxide, CO2. So that is what is reacting. And since we know what is reacting now, you cannot solve the question. We are looking for what volume of oxygen. We are looking for volume of oxygen now. And you know that 1 mole of oxygen at XTP is 22.4 dm³. So we are looking for volume of oxygen. But something is reacting. 60 grams of carbon. 60 grams of carbon is the one that is reacting. 60 grams of carbon is reacting. Because the question mentioned that 60 grams of carbon. And what are you going to do now? And this one is at XTP. So in order to solve this question, you can go by mole ratio again. How can you go by mole ratio? Now, you can use the proportion method, or 1 mole of carbon. 1 mole of carbon will give us what? 1 mole of carbon. 1 mole of carbon. 1 mole of carbon, which is 12 grams, gives what? Gives 22.4 dm³. 22.4 dm³ of O2. So 1 mole of carbon is 1 mole of carbon is 12 grams. And in this one for O2, 22.4 dm³. That is 1 mole. 1 mole of oxygen is 22.4 dm³. So 60 grams of carbon gives what? Gives X of oxygen. What we are saying is this: 12 grams of C of carbon, that is 1 mole, gives 20.4 dm³ of O2. So we are not saying 60 grams now of C now of carbon gives X in dm³ of O2. So that is what you are saying. So now what are we going to do? We want to find this. Use proportion method. X now becomes this times this. That's 60 times 22.4 divided by 12. That gives us X equals to 12 here 1, 12 here 5. That gives us 5 times 4 is 20, right? 0. Keep 2. 5 times 2 is 10. 5 times 2 is 10. 10 plus, what should I call it? 10 plus, what should we keep to? What will be 2? That will be 12. 2. Keep 1. So 2 times 5 is 10. Plus the one we keep, that is 11. So that gives us 112.0 dm³ of that. So that is when you are using this method. If you want to use another method, how can you solve it? Let's see. Number of mole, which is amount, equals to reacting mass all over molar mass. Reacting mass over molar mass. So number of mole equals to what's our reacting mass? Our reacting mass that was given in the question is 60 grams all over 12 grams per mole. All over 12 grams per mole. So now that gives us N equals to 5 mole. 5 mole. So we are having 5 mole of what? 5 mole of what? Of O2. And 1 mole of this we give 1 mole of this. Note that 1 mole of this we give 1 mole of this. So 5 mole of this we give 5 mole of this. So now, in order to know that 5 mole will give us 5 mole of O2. So now, since we are now having 5 mole of O2, so and now we are molar volume equals to what? Volume equals to number of mole equals to volume all over molar volume. Volume all over molar volume. So what is our volume? Our volume is what we are looking for. So that means we have what? We have volume to make the subject of the formula equals to number of mole times molar volume. So what is our number of mole? 5 times what is our molar volume? Our molar volume is 22.4 dm³. Our molar volume is 22.4 dm³. Our molar volume is 22.4 dm³. So that gives us 5 times 4 is 20. Write 0, keep 2. 5 times this, that's 10 plus 2, 12. Write 2, keep 1. 5 times 2, that's 10 plus 1 that we are keeping. You know that this times this will give us 20, we keep 2. So this times this is 10 plus that 2, 12, we keep 1. Now 2 times this, that's 10 plus 1, 11. So that gives us dm³. So any method you like, you can use. If you don't understand the video, watch it and watch it over again. Once you watch it, you can get the picture of the meaning of mass and volume relationship in a chemical reaction. If you watch those videos, you are going to get the relationship very well. Mass and chemical relationship. Before you talk about stoichiometry, you need to understand mass and volume relationship in a chemical reaction. If you watch this video, look at how we use one step to find it, and how we use another step, how we use mole ratio, and how we use normal method in order to solve for each question. We have used about 2 methods to solve at least 1 question. So if you use mass and volume relationship, if you understand mass and volume relationship, you cannot talk about stoichiometry, you cannot talk about dilution method and all those ones. But if you don't understand mass and volume relationship, there is no how you are going to get that. So my advice for you is that carry a textbook, sit down under the tree and read very well, so you are going to understand more better. So once you read, you are going to gain a lot of things. This video has summarized how chemical relationship, how we react equation together, and how we solve for chemical reaction. So mass, we have solved for it. Volume, we have solved for it. Relationship, we have known them all in a chemical reaction.